Codes like RSA are effectively uncrackable, because however powerful today's PCs are, they can only process one computation at a time. But now, scientists are working on a new form of computer that harnesses the most complex physics in the universe. The world we are all used to is a fairly reassuring place. The laws of physics mean we can know where things are, how fast they're moving, and predict where they're going to go. But as things get smaller, a lot smaller, they also get a whole lot weirder as you enter the world of quantum mechanics.
Quantum is like trying to see music. It's like even trying to hear color, right? It's very weird.
It's the world that Eric Lucero studies every day.
Take a single grain of sand, and in that single grain of sand, there are billions and billions of atoms. And what we're interested in is looking at what happens with a single atom. These kinds of scales are where nature shows itself in a completely different way, and that is this in quantum mechanical nature.
The laws of quantum physics have baffled the greatest scientists, even Einstein. At the smallest scales, the idea that we can know exactly where anything is starts to break down. The mathematics that describes the world of the very small means things can be in many places at the same time.
One of the very important features of quantum mechanics is this idea of superposition. And superposition is the idea that a particle can be both in one place or another place at the same time. If we speak about it even in a binary sense, like of 0 or 1, it can be both 0 and 1 at the same time, which is a very odd idea.
Superposition means that objects have no fixed location. They really are in several places all at the same time. These ideas may be mind-bogglingly weird, but they can also be very useful. And for Eric, they may be a way to crack the world's most powerful codes. Here at the University of California at Santa Barbara, Eric has constructed a machine that operates within this fantastical world.
Nice. Oh, this looks great. Oh, yeah.
He's harnessed this quantum weirdness to design a computer chip, a processor, that could be the first big step in creating the ultimate code-cracking machine. But first, it has to get very, very cold.
We have a dilution refrigerator, and this base plate right here is what gets a fraction above absolute zero. Orders of magnitude colder than space.
All of this machinery exists just to cool down the processor.
So inside of this specially engineered box, we have a quantum processor. It's a solid-state quantum processor. On this chip, there are 4 qubits, and the qubits themselves are what are performing the calculation.
Classical computers use data in the form of bits, each a 0 or a 1. Even with parallel processors tackling a problem at the same time, at the most basic level of computing, there is always a 0 or a 1. But a quantum bit, called a qubit, uses the feature of quantum physics that means things can be in 2 places at once. It can be a 0 and a 1, all at the same time. This gives the quantum processor the power to do many calculations simultaneously.
We mount this quantum processor onto the base plate here, and we then make all these electrical connections. And then we're able to move the quantum information all around that chip and then actually extract the answer. Okay, we're good. from a scientist's point of view, it's a very exciting tool that we could probe nature.
Yeah, nice.
But it's so fast that it could also eventually break the codes that now protect much of our secret data. To prove it in principle, Eric set out to use his processor to find the two prime numbers, the factors, of a small semi-prime.
And so it's sort of at the level of technology that I would say is maybe like an Atari, right? It's kind of 8-bit technology. And it was a very kind of neat toy problem, and that we've tried to find, using a quantum processor, the factors of 15. And I'll let everyone kind of think about that for a minute, but that is probably something that we all can do even in grade school. And it took me 7 years to get my physics Ph.D. to do that with a quantum processor.
What's remarkable is not the answer, but the way the processor does it. The quantum chip considers every possible solution all at the same time, instead of sequentially.
And you're collapsing to this one answer that will actually be the answer you're after, right? Which is a huge speed up, that you kind of explore all of these possible places and possible answers, and you get the one that you want. And we learn, yeah, yes indeed, 15 equals 3 times 5.
If the same can be done with giant prime numbers, then quantum computing has the potential to smash the codes that protect the internet in the form of RSA encryption.
It blows the doors off of RSA encryption, right? All we need is more and more qubits. We just need a larger quantum computer. Really, all that's left to do is to scale up this particular architecture. It's a big task, and there's a lot of very bright people that are all working towards that. And I think that what's exciting is it really puts kind of a milestone in the ground about where things are and kind of what we need to do next.
You do realize you've broken the internet now?
Oh, yeah, I'm sorry about that.